Yeah, good morning to another person here. In continuation with the previous video, so now we will continue the remaining content with respect to the CO3, that is nothing but estimate the energy performance of lighting systems. So in that we already discussed the following slides. That we will move to the light source. So far we discussed about the light basics, that is your terminologies, and how the lighting effect is initiated, how it excites our eye retina, all those things we discussed. So now, what are the light sources? Light sources means you can tell it is a tube light or incandescent lamp, CFL, so many types. That is lighting types. So here we are going to discuss what are all the sources. So only we have 4 sources, whatever may be the light equipment or appliances that works any one among these 4 sources. The first one is incandescence, that is thermoluminescence. Is by definition the radiation at high temperature. The radiation initiated with the help of high temperature. The source employing this process are incandescent lamps and gas lamps. So earlier you may see this incandescent lamp. Nowadays it is not that much available in practice. That is nothing but kundu bulb. So the incandescent lamp, which works on this incandescent principles. Tungsten element you need to heat for a higher temperature, and that higher temperature it emits the light energy. That is the principle. They lead to continuous spectrum of radiation. So where we have so many drawbacks that we will discuss in later. But this is the first principle of light source. The second thing is luminescence. That is the electroluminescence by definition, chemical or electrical action on the gases or vapor radiation. Here the color of radiation depends on the material employed. Usually this process leads to the line or band spectrum. So here you can see light emitting diodes. It's an example. Emit light via electroluminescence. So electrical action or chemical action. So phosphorus material that emits light when irradiated by the high energy electromagnetic radiation or particle radiations. So these are the examples for luminescence. Third one is fluorescence. The process in which the radiation is absorbed at one wavelength and radiated at another wavelength. So example is UV imprisonning or uranium fluorescent oils. This is re-radiation makes the light radiated visible. UV உள்ள வாங்கி வெளியே கொடுக்கும்போது visible spectrum convert பண்ணும். So that is fluorescence. Phosphorescence is a process when the energy is absorbed at some time and radiated later as glow. So it is almost like a storage purpose. Example of this purpose are luminous paints that contain calcium sulfide that lead to the phosphorescence. They produce light radiation after exposed to the light. So night houses sticker replace பண்றீங்களா, reflect ஆகும் அந்த மாதிரி. So when you observe light and then reflect, right, this is the phosphorescence. Among this 4 principle of light sources, you have so many options that we can see here. These are the types of lamps: arc lamp, incandescent lamp, halogen lamp, fluorescent lamp, compact fluorescent lamp, that is your CFL, sodium vapor lamp, mercury vapor lamp, metal halide lamp, light emitting lamps, all these things and more also. So this has nothing but incandescent lamp. I am not going to detail all those things. The key thing with respect to the incandescent lamp is a wire or filament heated to the incandescence by a flow of electrical current. Inert gas filled is argon, krypton or nitrogen. Commonly used inert gases are 88% of argon and 15% of nitrogen. When you analyze this lamp, your 100% electrical energy is converted into 70% infrared radiation. What is the meaning of that? Heat radiation which is not visible by your eyes. So 70% we are wasting, and 20% lost by conduction and convection. So the conduction and convection, that type of heat energy, and 70 plus 20, 90% we are wasting, and remaining 10% only, which is outside our eyes, that means invisible radiation. That's why nowadays we are not recommending this type of lamps. Even the production is minimized to the extreme minimum level. A very minimum amount of lamps are produced for some testing purposes. And next is halogen lamps. You may see these lamps in your vehicles. Tungsten filament plus halogen gas. Halogen gas increases the efficiency and light, ideal for the prices direction of light, but requires transformers. Low voltage types are very small. And this another is a fluorescent lamp. This you are already familiar. And here the fluorescent lamp energy aspect is 100%, is 30% becomes an infrared radiation, and 45% of conduction and convection, 20% is visible radiation. Compared to your incandescent, it is somewhat better. Compact fluorescent lamp, sodium vapor lamps, you just go through all those things, right? And so with respect to the sodium vapor lamp, I'm just discussing the familiar lamps alone. Low pressure sodium vapor lamp, it has a high intensity discharge lamp, which is a high intensity discharge lamp, high efficient in terms of light output divided by electrical input, but produced poor quality of light. It is monochromatic light. That means in the visible spectrum, this sodium vapor lamp produces only few colors. It won't produce all the colors in the visible spectrum. That's why it has a poor CRI, poor life also, used for outdoor applications. Earlier in the street lights which was used, so switch on panna piragu at least 10 minutes kalichu, which will give the light and which will give the very minimum amount of light, and but it serves the purpose with a high efficiency, since it's a high efficient. But nowadays it is also replaced with your CFLs. And in the continuation of sodium vapor lamp, high pressure lamps. Here it is also a high intensity discharge lamp. It has a starting electrode, and also it needs a ballast. It has a ceramic arc tube filled with inert gases of xenon as well as the sodium mercury mixture. It has high efficient in terms of electricity usage, but again it is also low in CRI. And with respect to the sodium vapor lamp, high pressure, 20% becomes infrared, 5% becomes ultraviolet radiation, 60% causes a loss, that is conduction losses, and 30% is visible radiation. Sorry. That's why these lights occupy the street lights in the earlier days compared to your incandescent lamp and fluorescent lamps. And next is mercury vapor lamp. Electromagnetic radiation created from the mercury vapor discharge during the operation of pressure in the bulb is this much. Initially, arc started because of argon used to vaporize the mercury. Metal halide lamps, so this is high pressure mercury vapor lamps, and me just go through these features of the metal halide lamps. And here the important thing is, with respect to the metal halide lamp, 20% becomes infrared radiation. And one more information, this type of diagram will be known as Sankey diagrams. S-A-N-K-U-Y, Sankey diagrams, which is used to usually represent the economic factors, how the economics is spent towards the multiple channels, or the energy spent in multiple channels. Likewise, you can represent this. And this is the with respect to this metal halide lamp, the 100% is spent towards infrared with a quantity of 20%, 5% of UV, and 50% of flash, and only remaining 25% is visible radiation. And another one is light emitting diode, and the internal efficacy ranges from 75 to 50 lumen per watts. So, which has a high efficacy. And here you can see various light efficiencies. So we just go through the slides, which has a lower one, which has higher one. You just check over this. And efficient lamps are compact fluorescent lamps, color of ET series tube lights, metal halide lamps, high pressure sodium vapor lamp, and LED lamp. These are the feasible lamps. Here you can see the exact comparison of its performances. Incandescent lamp, the light output divided by electrical input efficiency is average of 14, whereas your low pressure sodium vapor is 150. You see the difference. But in the incandescent, the color rendering index is high, and where your color rendering is poor. So in the showrooms, they will produce huge number of incandescent lamps in the earlier days. Nowadays, it has converted into halogen lamps. And you see the fluorescent lamp's average efficiency is 15, whereas your CFL is 60%. That's why we are promoting the replacement of fluorescent with CFL. You see all these factors, and these are the life hours for a particular light bulb will function for 100,000 hours. Similarly, this sodium lamp will function for 12,000 hours, and this is another 10,000 hours, and which has minimum amount of lifetime. Now, another important characteristics we need to familiarize effect of voltage on the lamp efficiency. This, you first see this characteristics curve. This curve, this side is efficiency and this side is voltage. When the voltage is only 90%, the efficiency is high. At 100%, the efficiency is 100%, almost closer to 100%. When your voltage is high, your efficiency is drastically reducing. This is the one factor you need to keep it in your mind. Whenever you have a low voltage, slightly low voltage, not the huge low voltage, the fluctuation is only 10%. That means if your voltage is 230, means maybe 210 voltages. Within the 210 voltage, you have some better performance in the lamps. When you go for the 10% variation, that is 240 something, 230 to 240 ranges, your efficiency will become less. And the same other way, power consumption is low on this side, and here it is power consumption is high, and luminous output is also low, and this side is high. Okay? And you need a main thing here. On the high voltage, your luminous output is high, whereas the power consumption is still high. That's why your efficiency becomes poor, right?